Welcome to the Tangram issue with battery testing. During this presentation, we will explore the product testing challenges in the EV industry as we reflect on two decades of EV automation.
Issue within battery testing virtual presentation. My name is Srđan Rejkovic, and I will be talking about some of the battery testing challenges with EV batteries evolvement at unprecedented pace. This presentation applies mainly to EV batteries and cylindrical cells, but it is transferable to the other battery types. I have been part of the ATS team for over 20 years, designing test systems in a variety of fields, including life sciences, consumer products, electronics, energy, and traditional automotive programs.
Hello, my name is David Geiler. I'm a test specialist here at ATS. I focus primarily on leak testing and the electrical connection interface to the product. I've been at ATS for 7 years designing test equipment for various industries, including medical, aerospace, energy grid, fuel cell, consumer products, and traditional automotive. With the shift to electrification, there have been a lot of opportunities to contribute to this exciting industry.
Today, we want to talk about four topics shown here. Why the cell is the first line of defense and not the module and pack. Top challenges for pack, module, and cell, and the nuances in each area. How modularity and flexibility give scale within a small footprint, capitalizing on capital expenditure. How manufacturing design authority can be a knowledge partner in battery testing to successfully scale and meet launch targets. According to predictions, electric vehicle sales could reach 33% globally by 2028 and 50% by 2035. To support that demand, automakers and suppliers now expect to invest at least 526 billion on electric vehicles and batteries from 2022 to 2026. Electric vehicle sales are surging due to a combination of policy support, improvements in battery technology, more charging infrastructure, and new compelling models from automakers. 53 trillion is size of the electric vehicle market opportunity between today and 2050. The demand for batteries is expected to grow by around 30%, nearing 4,500 gigawatt hours a year globally by 2030 and reach annual revenue as high as 410 billion. Approximately 90% of the demand will come from mobility applications, most importantly, electric vehicles. The global electric vehicle test equipment market size is is projected to reach 242 million USD by 2027. Battery testing as a part of electric vehicle testing is important and required during the development, validation, production, and post-production stages of electric vehicles.
ATS has over 20 years of battery manufacturing and testing experience. This testing experience includes having built 90 plus assembly lines for storage, and as well as including test systems. This is all built based on our ATS build business model, or ABM, which really focuses on three primary pillars. The first pillar, we recruit the best talent. We make sure that we have people that are going to give us that winning team. The second pillar is we focus on continuous improvement. We make sure that our process is sound and disciplined. Finally, we have the daily visual management, which tracks the performance and makes sure that we are always winning. We are able to win because we have a team of experts that know automation and test equipment. They are able to focus on delivering the best-in-class solutions. And this is all tied together with project management to make sure that we always foster positive customer relationships. We also have a global footprint, which allows us for global support and scale. ATS is incredibly stable as it's been around for over 40 years, and it expects a safe future. Here you can see our part of our global footprint and part of our global service. We do have our specialized test centers that are based out of Woodbridge and Wixom.
Battery cells are assembled into modules or packs, connected in series and parallel to achieve packs' total voltage and current requirements. One pack can contain several thousand individual cells. Once cells are assembled into the module or pack and welding process is finalized, it is very difficult and most likely might not be cost effective to replace defective cells. In case of thermal event, defective cell can damage a module and entire pack, not to mention safety risk. In April 2020, US NHTSA launched investigation looking into a safety-related defect in battery packs made by LG. According to the report, high voltage battery made by LG had a defect that could ignite inside the battery cell, raising the risk of a fire. As a result of that investigation, LG Energy Solution reimbursed GM $2 billion for the recall costs. This illustrates how important and critical is battery cell testing as a first line of defense. Remanufacture at module level. However, there is currently no industrial application of remanufacturing up to a cell level of batteries with a lithium-ion cell chemistry and welded cells, as the state of the art of the most current electric vehicle models are. In fact, while the first electric car batteries were assembled in small volumes and bolted connections were acceptable, the demands of high volume manufacturing for stable and fast processes, as well as small and less variable contact resistance, are better met by welding. The number of cells in pack can be thousands. Each of those cells has to be tested for OCV and AC internal resistance before they got assembled into a module or pack. The test time for each cell significantly affects throughput of the battery packs. So we want to test that larger number of cells as fast as possible. In order to minimize test time and still have consistent and accurate results, the best approach is to automate the test and use a multi-channel multiplexer and bed of nails test fixture. Every bed of nails has a certain number of nests. In our case, is up to 64. Every nest has 4 pins to accommodate 4 wire resistant measurements. Once the contact was made with cell, multiplexer starts scanning each of the cells so OCV and ACR measurement can be taken. This scan is executed sequentially with smaller number of cells that might be fast enough. But for larger number of cells, we might need to increase the test circuit 2, 3, 4 times or even more in order to achieve acceptable test time and throughput. In fully automated assembly lines, tests can be also executed during the robot pick and place time interval. In this case, there is no need for bed of nails. Cable lengths of the measurement circuit, to be more specific, length from instruments to the test probes, can affect test results and test time. Longer cables can cause a decline in measurement signal quality. Also, the total resistance can be increased above acceptable tolerance specified by instrument specification. In that case, stated instrument accuracy is not valid anymore. In that case, stated instrument accuracy is not valid anymore. To compensate that degradation of the signal, we might not be able to use fast measurement mode, which means longer cycle time. The best, the best practice is to have a short cable as possible. Unfortunately, in production environment, that is not always possible. Actually, due to limited footprint, very often we needed to move instrumentation further away from the test probes. So we developed a better layout to incorporate the test tooling directly into the automation. This modular method enabled the tools to be placed closer to the item being tested to allow for more accurate testing, lower cycle time, and increased throughput. Here we can see the main screen of one of our battery cell tester application. It shows the results of 256 individual cell tested for open circuit voltage and AC internal resistance. Color-coded Color-coded shading provides visual feedback of the status of each individual cell. Data can be uploaded to remote server farm for in-process pass-fail determination, or pass-fail determination can be done locally. In this particular case, all 256 cells are tested in less than 10 seconds. If we do some math, we can see that more than 700 cells can be tested for less than 30 seconds. While I'm here, I would like to mention the key features of our ATS battery cell test system as a standard product. These are scalability, modularity, and flexibility. ATS test executive features built in the system. High accuracy and precision instrumentation to measure open circuit voltage and AC internal resistance, four wire measurements for AC internal resistance, high-speed multiplexer to switch through the 256 cells. Using four-quadrant bed of nails concept allows test time per cell to be less than 10 milliseconds. It has probe bed of nails to test up to 256 batteries per tray as a standard. Optionally, the number of tested cells can be extended above 256. We start out with thousands of cells in product, and that means we need to be testing thousands of them at the start. As you move down the assembly process, these products are highly modular, built up little packs or sections or modules that consist of some number of cells or pouches or energy storage devices. Maybe it is 300, maybe it is 300 or 500 per sections or module. Now our rate that we need to process and run tests on starts to slow down. We now look at the number of seconds per parameter we are dealing with. When we get to the end, we have a single completed pack and we are looking at maybe minutes per part. Not only that we have to look at the quantity of parts, but the intermingled process. Parts connections change. If you look at testing across for these parts, we are testing the same physical quantities as we go down the line. We have different connections for doing this. We have high voltage DC connections, typically more towards the end of the line as the voltage just gets built up, and we have low voltage DC connections that are usable for controlling per charge discharge. For all levels, cell, module, and packs, testing, the core challenges are the same. How to accommodate more and more demanding requirements for smaller footprint, higher accuracy, shorter cycle time, lower cost, faster delivery time, and higher power. Every application is different. What kind of testing is required depends on application. There is a variety of different types of modules and packs based on pack manufacturer's preference. Modules can have different size and shape, different configurations, meaning different combinations of number of cells connected in series and parallel. For example, it can be 54 3S and 2P, 14S, 2P, 3S 40P, or 11S 60P. Depending on configuration, modules can have voltages from dozen to more than 100 volts and current capacity from 5 to more than 500 ampere hours. Some of them don't have cell management controllers. The ones they have cell management controllers can be with or without battery management controller. BMC can have different topologies, different communication protocols like CAN bus, ISO-SPI, ISO-UART. The same way packs can have different size and shape, different configurations, meaning different number of modules connected in series. Connected modules can be of different types. Depending on configuration, pack can have voltages from 100 to more than 1000 volts and current capacity from 10 to more than 1000 ampere hours. Different battery management systems with different topologies, different communication protocols. For example, CAN bus, LIN bus, RS232, RS485, and Modbus. Some of battery management systems can include separate battery electronic control module and a battery electric module. To accommodate all above mentioned varieties and future upgrades, ATS developed battery module and pack test systems as a standard products, which will be presented in one of the following slides. They can be they can be modified when needed for slight cost and time. They can be modified when needed for slight cost and time addition. In combination with universal fixture, ATS battery module and pack test systems can get covered testing for all your different part types and future upgrades in a single footprint. Custom-built specific test systems with flexibility, modularity, and scalability is imperative. Modularity allows faster and less expensive installation. Upgrades are faster and cheaper than the purchase of new system.
When we talk about module testing and needing to connect to modules, we have in the previous slide, you could see different variations of what you could imagine in a module. You could get short modules, tall modules, just a whole bunch of different connections are possible in a module. So to be able to accommodate all these different connections and to have a connection that is reliable, which is required for testing, we have come up with a custom connection that is based on a standard platform. Most customers expect to be able to get off-the-shelf components, but it has been shown through our experience that these off-the-shelf components are not always the most reliable or designed to have the best life. We at ATS Test have an in-house connector department. So we've been doing these custom connectors for over 20 years, and we believe that we have over 5,000 connectors supplied. One of the big advantages of these connectors is that they are serviceable. They are designed in such a way that the contact component that contacts the customer product or the customer mating connector is designed in such a way that it can be removed and replaced as part of a service process. The connectors are very robust and are expected to have a very long life. Now let's talk about leak testing. ATS has had a long history of leak testing. It is quite a unique story. So we've been doing leak testing systems for over 20 years. We used to specialize only in small and complex leak tests. Now we've expanded that knowledge base to larger leak tests, in such as a case you would see in a pack. One of the examples that we have here is we needed to detect a 10 milliliter of air loss in a volume of 250,000 milliliters, which really equates to a teaspoon in a bathtub. Packs need to make sure that they are impervious to liquids entering to make sure that the packs themselves do not get damaged. The inside is full of live electric cells. And as everyone knows, electricity and water are not friends. So a lot of suppliers come up with ingress protection ratings or IP ratings. And most of the time we see IP ratings in the IPX6 or 7 range to make sure that the water is not entering the product. There is two ways for water or fluid to enter the product. This would be once the pack is in vehicle and it is seeing rain or snow, salt or sand trying to get in from the outside. You can also see fluid coming into the pack from the inside, from the coolant. Most packs have coolant systems to keep the cells cool. And because you don't want the coolant to leak out inside your pack, it also needs to be tested. Now, when you're testing a large pack for a very small air loss, it's going to take time. It is also very susceptible to temperature changes and environmental changes. There are other options than air leak testing for these packs, such as a helium mass spec system. However, we have seen that the cost of operation of these systems and sourcing the helium as a tracer gas can be difficult for most customers. The advantage of air is it ultimately reduces the operating cost, as most manufacturing environments will have compressed air at the ready.
With all those existing and future varieties of different module and pack types, scalability, modularity, and flexibility is must. In this slide, I will present capabilities of ATS battery module and pack test systems in that regard. There are three basic systems as the standard products. Type 1, which is on the left, covers test applications for battery modules and battery packs with lower current rating. Maximum ratings for these products are 60 kilowatts, 950 volts, 750 amps. Depending on module or pack type, test system can be configured in different combinations and used for testing. For example, one module with voltages up to 150 volts and currents up to 400 amps. Two modules at the same time with voltages up to 150 volts and currents up to 200 amps. Also can be used to test one module with voltages up to 80 volts and currents up to 750 amps, or one pack with voltages up to 500 volts and currents up to 120 amps. Type 2, which is in the middle, covers test application for battery packs. Maximum ratings for this product are 200 kilowatts, 1000 volts, and 400 amps. Again, depending on pack type, it can be configured in different combinations and used for testing. For example, one pack with voltages up to 500 volts and currents up to 400 amps, or two packs at the same time with voltages up to 500 volts and currents up to 200 amps. Type 3, which is on the right, covers test applications for battery packs as well. Maximum ratings for these products are 400 kilowatts, 1000 volts, and 800 amps. Depending on pack type, it can be configured in different combinations and used for testing. Again, for example, one pack with voltages up to 500 volts and currents up to 800 amps, or 2 packs at the same time with voltages up to 500 volts and currents up to 400 amps. Here, I would like to say that these ratings are for standard products. As an option, ratings can be extended to 600 kilowatts for power, 2000 volts for voltage, and 1200 amps for current. To summarize, ATS battery module and pack test systems can be configured in so many combinations that can be covered that can cover almost any part type variant as long as power, voltage, and current requirements are below limits specified above. With ATS battery module and pack test systems, you can have all your part type variants tested in one line, meaning smaller footprint with better return of capital investment. The key features of these systems are scalability, modularity, and flexibility. ATS test executive features built in the system. 3 independent measurement systems, DMM, data acquisition, RPS, are measuring the same test points. Comparing the readings minimizes possibility of passing bad part. Very accurate current programming, ultra-fast up-down programming speed, auto-ranging output for greater flexibility, accurate programming and measurement, LAN interface as a standard, and AC input 3-phase, 200, 208, and 400, 480 volts. ATS test regenerative power system is bidirectional regenerative DC power supply. The regenerative capability enables the energy normally consumed to be returned to the grid cleanly, saving costs associated with energy consumption and cooling. Operates in 2 quadrant mode as power source and regenerative electronic load. Continuously source and sink current up to 100% of its rated current for an indefinite time. Seamless, uninterrupted transitions between sourcing and sinking current without changing the power supply's output characteristics or introducing any disruptive behavior. Built-in overvoltage, overcurrent, and overtemperature protection. Test systems also include low voltage test, battery management system test, communication protocol check for protocols like CAN bus, LIN bus, RS-232, RS-232, RS-485, and Modbus, ISO-SPI, and ISO-UART. Also includes cell management controller check, DC to DC low voltage check, and vehicle environment simulation. Hypotest is also part of this test system. Insulation resistance, withstand voltage, and ground bond test. And in the end, we have high voltage test. Open circuit voltage, contactors, interlock circuit check, current reading, pre-charge, DCIR, charge discharge to delivery state of charge, drive cycles on or according to already defined standards. As mentioned before, ATS Test Executive is part of our test systems. It is custom test software and can be easily customized to meet each customer's unique requirements. It has been deployed more than 500 times in multiple market segments with multi-language support. ATS Test Executive software backbone are powerful user customization, programmable and configurable through scripting environment, pass-fail determination based on user configurable settings around each measurement made. Data is archived for easy recollection, intuitive visual tools, color-coded results, displays, messaging graphs, and diagnostic features. Incorporating readily available industry standard measurements devices. For example, to illustrate how Test Executive is user-friendly, I would like to say that I did myself a number of projects using this software, and I'm not a software person. So if I can do it, everybody can do it. For more information, you can visit our website using link on this slide. Okay, for more information, you can visit our website using a link in previous slide. ATS, other than Test Executive, provided software for sequence automation, manufacturing solution, and reporting analysis line production history. For more information, you can visit our website using links in this slide. Knowing that batteries in either modules or packs meet their desired matrix is essential to validate key processes before ramping up to production. Whether incoming cell inspections such as open circuit voltage measurement or leak testing on the coolant circuit, each successful production line has both inline and offline testing to help minimize scrap and ensure a quality product. Other essential testing requirements are likely to include high pot test, DCR testing, and low voltage circuit testing to validate that battery's internal voltage monitoring system is functioning correctly. To couple with the connection points of the cell, module, or pack, the automation tooling may require custom connectors to ensure long-lasting and reliable contact. On the back end of testing is the data banking of all this information, so each product has a creditable birth certificate from the production floor to the final customer. ATS battery test systems is up to nowadays requirements and can meet. Okay, since it is very important, I repeat again. ATS battery test systems is up to the nowadays requirements and can meet.
A few takeaways here. I think it's important repeating why having a design authority as a partner is so important. We know what works and we know what doesn't and why. What design authority does for our customers is it allows them to get to the market in the fastest and most reliable way, making use of strategies to mitigate schedule and reduce risk. A partnership with a design authority is what's necessary to stay ahead in today's competitive electrical vehicle landscape.
I want to close by saying, on personal level, how excited I am to be part of an organization that is shaping the future of the automotive industry and one that has experience and confidence to make a difference to our customers. I see a bright future for what electric vehicles mean to our everyday way of life, not only for obvious environmental and energy security reasons, but also for pure driving enjoyment and mobility opportunities for upcoming generations. Because of this, it is clear to me and all of us at ATS that every day matters to bring this future to reality. Thank you very much for your attention today, and I look forward to working with you in the future.